Hello, welcome to this tutorial. In this lesson, I'll be teaching on how to calculate the quantity that should be produced if there are two firms in an industry. Okay? Now, what we are looking at is basically what we call the Cournot model in a duopoly. A duopoly is a situation where we only have two firms, and these two firms, they are reacting at the same time. This is one of the concepts in game theory. So I'll demonstrate how we calculate the quantity that each firm should produce and what the ideal price would be based on a Cournot model in a duopoly. So there are two models basically that we actually look at when it comes to game theory, which are cardinal: Cournot and Steckelberg. Steckelberg is where one firm leads the market and the other firm reacts. But at this point, we are looking at a situation where both firms will react at the same time, and then we'll calculate the ideal quantity that each firm should produce in order to maximize profit in an industry. All right, thank you. So here is an example. Two firms with a demand curve. 100 is equal to 1000 is P is equal to 1000 minus Qi, where Qi is basically the quantity for two goods. This one, the Qi, it's the quantity for two goods. So what we are simply saying, Qi is basically equal to quantity for product A, Qs, and quantity for product A. So we have got Qs plus Qa in Qi. And then we have the cost function here. The total cost function is 25,000 plus 100 Qi again. When we say Qi here, we mean in this quantity there is quantity S plus quantity A. Okay, so first things first is to break down the equation in a manner that will help us to proceed with the computations. So we have P here being equal to 1000 minus, where there is Qi there, I'll replace this time around. I'll replace by opening the bracket, putting Qs plus Qa. All right. Now to break this down further, I'll simply say price is equal to 1000. This negative will have an impact on the Qs there. So I have negative Qs. And then this negative, again, negative and positive, it will make a negative. This will be negative Qa. So I've broken it down that way. Okay. And then what am I supposed to do? I'm supposed first to find what we are calling as the reaction function for firm producing S. So this firm producing firm S producing those products, we're going to say that the products are basically identical in nature, but then what it is here is that this firm will produce that quantity and this firm will produce that quantity. So they are sharing the market actually for the same or similar product. Okay. Now, this is what will happen here. If I'm attempting to find the reaction function or the best response for firm S, what I'll do is I need to find its profit maximizing position, which is basically marginal revenue is equal to marginal cost. This is where the firms maximize their profits. So the setting for profit maximization in economics is basically marginal revenue is equal to marginal cost, in exception of a perfect competition market, which I already discussed in one of my other videos. Alright, so marginal revenue should equal to marginal cost. Alright, so for me to find marginal revenue, I need to find the total revenue of firm S. So total revenue of firm S, total revenue is basically calculated by simply multiplying the price multiplied by the quantity. Total revenue is basically the number of units that we are selling multiplied by the price for those units that we are selling. Okay? So I'll be quick here. So total revenue for product S is basically price. So price is here already, as you can see. P is equal to that. So price is 1000 minus QS minus QA. Okay? This price you are seeing here, I want to show you something. I deliberately wrote this. I'm going to delete it just now. If you see this and that, they are basically the same. What I was trying to indicate here is their situation where the examiner has felt pity for you and he has already expanded quantity 1, quantity S and quantity A. But ideally, a question has to come in that manner where the examiner just indicates that, so that you replace that. When we replace that in here, it comes to this. But when the examiner gives you something like this, just know in your mind to say the examiner has already simplified your weight. You don't need to do what I've done here. That's why I wrote that equation there. And then for total cost, as you can see, there is QA here, QI. In this QI, there is QS and QA. So meaning you have two total cost functions, which we are going to discuss just now. So when you say total cost of this nature and the total cost of that nature, the two there, meaning the examiner has already replaced two total costs. He has given you the first total cost and the second total cost, which is quantity S and quantity A. So I can delete this now. I've explained. All right. So now we are here. Okay. So we are applying this because I'm dealing with total revenue for product for firm S. What I'll do is I'll multiply this by QS. All right. And then our total revenue for firm S being 1000 S minus Q squared S minus, okay, this QS multiplied by that will be QS squared, yes. Then QS multiplied by QA, that will be QS. Beg your pardon, here is supposed to be 1000 multiplied by QS. So it's 1000 multiplied by that QS. So the QS is multiplying everything which is inside it. QS multiplied by 1000 QS multiplied by QS squared. I maintain the sign here, the negative sign. And then QS multiplied by QA, it's QS, like that. Now here I can find the marginal revenue. I already demonstrated to say marginal revenue is basically the derivative of total revenue function. Okay, marginal revenue is basically the derivative of total revenue functions. For those of you who did not see my previous video, I said when we are derivating or we are finding the derivative of something, we are basically going to multiply the power here, multiply by the number in front there, that will be 12, and then we'll maintain the x there, and then we'll say this power minus 1, it gives me 2. So like this, I'll have derivated what I wanted to derivate, okay? So the derivative, we're just basically talking about simple calculus. So in the event where you have something like this, and then you're derivating it, it's important that I go through the basic rules because you'll be wondering where I'm getting the numbers from. Where we have something like this means that the power there is basically 1, but we don't usually indicate it, so we leave it like that. So there is a 1 power there. So 1 multiplied by 12 will be 12, and then we maintain the x. And then here, 1 minus 1, it's a 0. Anything raised to the power 0 is equal to 1. So this is as good as, because the x is raised to the power 0 there, this is as good as there is a 1 here. So 12 multiplied by 1 will be 12. Others will say if anything is raised to the power 0, just collapse it. So here we are just collapsing the x, so we'll remain with 12 there. But to be prudent, we simply say anything raised to the power 0 is equal to 1. So that x becomes a 1, and then when you multiply by 12, it becomes a 12. Alright, so it doesn't matter the bigger the number, even if it's 1,000, 2,000, 4,000, as long as it's raised to the power 0, just know that the answer will be 1. Okay, so I'm derivating here, beg your pardon, I'm derivating here, and this QS is raised to the power 1, like we discussed. This QS is equal to the power 1, so this will multiply with the 1,000 in front here, that will be 1,000. 1 multiplied by 1,000 will be 1,000, and then when we say 1 minus 1, that will be a 0, and we'll say QS is raised to the power 0, so it becomes a 1, and at that point QS just collapses. Okay, we come here, we have 2 there, 2 here, it's like there is a negative 1, so 2 multiplied by negative 1, which is in front there, it will be 2, and then QS here, and then 2 minus 1, that will be 1. There is a 1 here, but we don't usually indicate it because it's a 1, so we just leave it as 2QS. Alright? Again, I come here. What I'll do here is I'll say this one is also raised to the power 1. So what is in front here is like there is a 1 here, negative 1. So 1 multiplied by negative 1, that will be 1. And then the QS will say 1 minus 1 there will be 0, meaning the QS will be raised to the power 0, meaning the QS will collapse, only leaving QA here. Okay, so we have that as our marginal revenue. Now we need to find the marginal cost because the setting is that marginal revenue should equal to marginal cost. So I need to calculate the marginal cost as with regard to firm S. Okay, as with regard to firm S, there are 2 firms here. So 25,000 plus 100. Instead of saying 100 QA, I'll say QI. I'll say 100 QS because I'm dealing with the total function for firm S. Remember, in this Q, in this 100 there is QA and QS. Alright, so I can replace this Q with QA plus QS, which will give me that. So I've replaced the QI. This is a QI. I've replaced it with that because we are saying QI is equal to that. Alright, so now with this being said, yes, with this being said, I can expand these 2 C's, 25,000, that plus 100 QS plus 100 QA. I've expanded now from here. I can find the marginal cost as with regard to firm S. So when we are derivating, I'm derivating where there is just QS. I can't see any QS here. So meaning that I'll leave it in my derivative equation. Okay, there is a QS here. There's a QS here, so this is raised to the power 1. 1 multiplied by that will be 100 QS, of course, yes. And then 1 minus 1 there will be 0. So if this QS will be raised to the power 0, it simply means that the Q will collapse. Okay? The Q will collapse because anything raised to the power 0 is equal to 1. So it's as good as just saying 1 multiplied by 100, and then it will still remain to be 100. So that's my marginal cost. Why am I not derivating this one? Because in this part there is no QS. It's different where we had QA and QS. In this part there was a QS. In this part there is no QS, so I'll leave it out. Here there was no QS, I've left it out. I just dealt with where there was a QS here, and then that's my marginal cost. And then the setting is that profit is maximized where marginal revenue is equal to marginal cost, as you can see there. So my marginal revenue is here. So I have a 1000 here minus 2QS minus QA is equal to 100. 100 is my marginal cost there. My marginal revenue, this one I've just indicated it there to replace that. My marginal cost to replace that. Okay, now I have this kind of a setting here. Since I'm dealing with QAs, I'll make QAs the subject to the formula, so everything else has to go that side. So I'll remain with the 2QAs here, and then we have the 100 this side. A 1000 goes that side, it will be negative 1000. And then a negative QA jumping to this side, it will be a positive QA. And then I need to get rid of the negative 2 here. Okay? Or maybe let me simplify it further so that it's easy. So 100 minus 1000, that gives me negative 900 plus QA here, and then negative 2 this side, negative 2 this side, negative 2 this side. Okay, I'm cancelling those two, and then I have QS here is equal to negative 2 into negative 900, or negative 900 divided by negative 2, that's positive 450. And then here we assume always to say there's a 1 here, so we are simply saying positive 1 divided by negative 2 will have negative 0.5. So this is just as good as negative 2 going into positive 1. Okay, so it's just positive 1 divided by negative 2, 0.5 QA as the case will be. All right. So now here we have this function. We shall call this function as the reaction function for QS. Now I need to calculate the reaction function for QA, company A. Okay? Meaning I'm going to do the entire process like I've done as with regard to QS. But hey, there is a good news that I can tell you. The good news is that the reaction function for firm A is the direct opposite of the reaction function for firm S. What do I mean? I simply mean it's a mirror. Meaning where there is S in this reaction function, we are going to put A. And where there is A in this reaction function, we are going to put S. So let's see how this will work out. Here it says QS, instead of saying Q, let me even indicate, this is reaction function, or best response for firm S. Okay? And then reaction function for firm A. Remember, this is not an equal sign. We cannot have two equal signs in one equation. I'm just pointing to say this is what it belongs to. So the reaction function will be Q. Where there is S here, I shall put A is equal to 450 minus 0.5 Q. Where there is A here, I shall put S. That's what I meant. But otherwise, if you wish, you do the process by multiplying and finding the total revenue for A and then doing the marginal revenue for A and something like that, but you just waste time because the answer was to come to this. So this is the reaction function for the second firm. Okay, so now I have two reaction functions. It is now easy for me to calculate the quantity for S, because the quantity for S is basically this one, 450 minus 0.5 QA. Where there is QA here, I can replace with that. Remember, we are saying QA is equal to 450 minus 0.5 QS. Okay? So what it implies is the QA is the same as that. So meaning where there is a QA here, I can replace the entire function there so that I can have everything in terms of S, and then I can calculate the quantity for S. So I'll bring it here and say 450 minus 0.5 QS there. Alright? And then we can start expanding. So this will be QS is equal to 450 here, negative 0.5 multiplied by 450, so 0.5 multiplied by 450 gives me negative 225, correct? And then negative 0.5 multiplied by negative 0.5 here will give me positive 0.25 QS, of course. Alright, so I just did this multiplied by that, and then the same one again multiplied by that to expand the brackets. So here it was negative 0.5 multiplied by positive 450, and then here it was negative 0.5 multiplied by negative 0.5 QS give us that. Alright, so now we have this. So now 450 minus 225, it is giving me 225 plus 0.25 QS, and then I have my QS this side. So the QS this side and the QS this side, they can be on the same side because they are like terms. So QS minus this will become a negative 0.25 QS is going to give us 225. All right. So now we have this one is as good as 1 QS, but we don't indicate the one. You know the rules. I'll not discuss that. I've overemphasized on that one. So QS minus 0.25 QS is as good as 1 minus 0.25 QS. 1 QS minus 0.5 QS will give us 1 minus 0.25 will give us 0.75. So I have 0.75 QS is equal to 225. We are fighting for QS, so I'll divide both sides by 0.75. 0.75 here, and then my QS will be 225 divided by 0.75. It's giving me 300 units. Okay, so now what this entails is that this firm S should produce 300 units, but we also need to know how many units should firm A produce. Since at Cournot QS is equal to what? To QA, therefore QA also will produce the same units, which is 300 units. This is as simple as that. So now here we have that. So the quantity that should be produced by two firms is 300 each. So we can find the price. The price is equal to that. Remember here. The price is equal to that. Price is equal to 1000 QI. Remember QI is equal to quantity produced by firm S and quantity produced by firm A. So I'll replace that. That's 1000 price minus 300. That's the quantity produced by firm S, and 300 is the quantity produced by firm A. So QI, that's it. So we'll just subtract both or the total quantity to say that's 600, and then we can say therefore our price is actually 400. All right, so this is how we deal with a problem which involves a duopoly or Cournot model, but we'll discuss a duopoly in the other video as with regard to Stackelberg, where one firm enters the market, they become a market leader, and then the other firm reacts in response to what the first firm has done. There, the quantities will be different. Here, the quantities are the same because the firms are reacting at the same time. Thank you.